Hello, everyone. This is SHAO from Jinan University. I'm atmospheric chemist. Okay, thanks very much for this opportunity to share with you our recent work on higher toxic organics production due to oxidation. You all know basically that atmospheric oxidation process is a degradation, but we did find very high toxic compounds, intermediate compounds formed in this case. So I want to use the isocyanic acid for our foci of this talk today. I want to go in these four aspects. First, the introduction. You know that the isocyanic acid is actually a very weak acid in ambient air, but it's also a very strong toxic species because it's water soluble at the human body condition, and it can go into the blood, and through the proton carbonylation process and cause a lot of inflammation to cardiovascular and respiratory disease. So it's highly toxic compounds in the air. From recent study about the threshold of these HNCO compounds is believed to be 1 ppb. So when the ambient concentration go above 1 ppb, it get a problem, damage to human body. We find that there are very sparse study on this isocyanic acid, mainly model work. From current model run, we find that this concentration just around 22.2 ppb in the air. But this is really true? We didn't find many ambient measurement data. So due to technical difficulty, the measurement data are very much needed. So for this purpose, I want to talk about this efforts of our group, how to develop measurement technically and do the field measurement for these compounds. Actually, the chemical ionization mass spectrometer enhances the capacity greatly to measure more organic compounds in the air. So we developed the whole system for the calibration and also the measurements of this isocyanic acid in the ambient air in both gas phase and particle phase. We also did the calibration for this methodology and did the relative humidity correction for real measurement in the air. And we did field measurements in North China Plain area and also in Pearl River Delta area. So by using this data together with other measurements for VOCs, CO, and ozone, PAN together, trying to understand the atmospheric oxidation process, we want to explore the source of isocyanic acid in the air. First, we compare the data we measured in Pearl River Delta and in North China Plain with other measurement data now available around the globe. You find that the measurement data in China is in the media level, is lower than data get from India and Nepal, but much higher than the other regions like the United States and Canada. And from our campaign, it's about 20 days and 5 days in Pearl River Delta and the North China Plain, but 38% of the frequency in Pearl River Delta exceeds the threshold of 1 ppb, and about 17% in North China Plain have this exceedance. That means the problem is actually quite serious. If we want to try and understand the behavior, we first look at the diurnal variation of the isocyanic acid. We find, we compare this diurnal variation from other areas in the world and find the diurnal variation in different places differed a lot. We summarize it here. This hints that the source of the isocyanic acid is quite complex. And when we compare this with the primary species and secondary species, we find in Pearl River Delta that the HNCO variation differs largely from this primary species, but it's have very similar pattern with this secondary species. Hence, the large fraction of isocyanic acids comes from secondary process. But this is different from the lost China plain. Actually, the lost China plain, there is no evident standard variation was observed. So means the primary and secondary both have significant contribution to this isocyanic acid in the air in northern part of China. And we also compared the isocyanic acid with the tracers of biomass burning. Some work say this kind of compounds mainly from biomass burning, but we find that in China, either with levoglucosan in the particle phase and acetyl in the gas phase, there's two tracers of biomass burning. The isocyanic acid behave very different from these two species. So we believe that biomass burning is not an explanation for the higher concentration of isocyanic acids. And there is a very important issue to improve the model run for this kind of intermediate compounds is the lifetime of the HNCO. So we compare the different processes that may contribute the decay of the isocyanic acid for the gas phase photochemistry, heterogeneous uptake and the hydrolysis, and the dry deposition. And we find that the dry deposition might be the key factors controlling the lifetime. So we estimate the average concentration in daytime and nighttime, and also the behavior in the residue layer, boundary layer, and the lower level of atmosphere. We estimate the lifetime of the isocyanic acid in the daytime is about 6.5 hours and 2.6 hours. And the effective lifetime, if this compound goes to the residue level, then the effective lifetime could be around 16 hours. So this data can be used to modify the current model run for this kind of compounds to get better prediction for this compound. Another issue is we're trying to understand what precursors contribute to the secondary isocyanic acid, and we using this sort of ratio to carbon monoxide to derive the contribution of primary, and by subtract the primary and get the part of the secondary process and estimate the current understanding. From this bar, you can see the red bar is the production rate of isocyanic acid from measured concentration. And the middle one is all the believed precursors from current reported conversion yield, the estimation of this HNCO production. You find very, very different large gap between these two figures. That means there is a very large missing of isocyanic acid precursors and probably the oxidation process. And if we assume that all the amides 100% nitrogen convert to isocyanic acid, then the estimations get a little bit better. It's about half of these formed isocyanic acid can be explained by this amide, and 70% comes from the C3 amide. So we think that both the precursors and also the oxidation process to fully understand or quantitatively understand the formation of isocyanic acid is still needed. So for further information, we published this work on the EST this year, and we need further work to understand how to quantify, then better predict this kind of toxic intermediate compounds from the VOC degradation in air. And will this kind of oxidation promote more toxic species? And how to evaluate this sort of toxicity change in the VOC degradation in the air is going to be very interesting for further work. Thank you very much for your attention.